Yeah, we're about to begin the final phase of today's talk. We deliberately put these two items toward the end of the program, not because we thought they had less significance. In fact, they perhaps have more significance than many things. We heard fantastic things today, I think you'll agree. Amazing discoveries, amazing theories, wonderful work that is going on. But there are two offshoots that have occurred. One began as a result of the publication in Popular Science, which shows the value of the press, why the press is absolutely critical to this field. James Griggs of Hydrodynamics Corporation of Rome, Georgia, was about to address you about a hypersonic pump. Would not have met the cold fusion field at all had it not been for this article, I think. Jerry Bishop wrote this in August '93, Popular Science. Jim Griggs called up Jed Rockwell and then myself and got involved. And we found out that this device that he has, a rotating device, which had no intention of being in the cold fusion field or in overunity or more energy out than indeed appears to be one of the most spectacular such devices. My own personal opinion, and this is just my view, but it also happens to be the view, I must say, tell you now, of a formerly very conservative mainline cold fusion physicist, Talbot Shove, of the Naval Research Lab. He believes that this device is real, that the excess energy in kilowatts is real. So without decision, what's this? That was August '93. Okay, I'm going to introduce Jim Griggs, who is an electrical engineer, and he has 15 years of experience in the energy conservation field. He's a senior member of the Association of Energy Engineers. He's a member of the NSPE inventory of the hypersonic pump. And he's the vice president of Hydrodynamics Incorporated. All right? Jim, delighted that you could come here, and we look forward to what you have to say.
First of all, I want to thank Gene for inviting me. He gave you a little bit of a history of about how we met and how we came together, and I guess my tie to the cold fusion field. I can assure you, having to follow Dr. Johnston and Dr. Hagelstein, that I'm not going to bore you with theory, because I have none. Peter talked to you about what he knew and what he didn't know. I'm going to talk to you about what I don't know and what I hope to learn. Because we kind of fell into this field by accident. Gene's already told you, I read that article and was very pleased to find out that there were other people around the world at that time who were being called some of the same names I had for the past 3 or 4 years. I'll give you a little basic background real quick on how this pump, as we call it, pump is really a misnomer, but how it came into being. Gene mentioned to you I'm an electrical engineer, and I specialized for about 15 years up until 1990 in designing basically computer control systems to control energy consumption in buildings. And I was in St. Louis, Missouri working on a project, and they had a water hammer problem with feed lines to a new boiler. And I noticed the pipe change temperature. I talked with the civil engineer who was in charge of the job, and he said, "Oh, it's just water hammer, forget about it, we'll take care of it." Remembering a little bit about water hammer, I went back and looked it up, and there's basically one sentence in water hammer that relates to what we're doing. In water hammer, it states that there's a minute of energy released into the fluid when a shock wave is produced. It also goes on to say that this energy is so minuscule, forget about it in your calculations, and here's how to get rid of the shock wave. Well, I'm just an old Georgia boy, so I decided, well, what would happen if? And that led me to start working on this pump. The first working prototype from the design that we're using now came about in 1988. And about 4 months after that, as we started drilling and changing new rotors, this phenomenon of excess energy appeared. where we were getting more energy out than we were measuring in the form of electrical energy going in. Well, doing energy audits for the past 15 years, I knew that could not be. So called in a couple of my acquaintances. We looked at this thing for about 6 months. All these measurements persisted. We put it away. Just closed the garage door, said I'm not going to worry with it. I'm going back to work, get back into the mainstream of things. But I kept tinkering with it over the years, and in 1989 I had the opportunity where a gentleman needed a boiler replacement, and he couldn't replace his existing boiler because of grandfather clauses, and he didn't have any other option for steam except to go buy an electric boiler. And I said, let's try something. And we put the first one in, and it worked. In 1990 we started hydrodynamics, and I've been full-time doing this ever since. And this energy phenomena has persisted. And I guess the thing that really excited me when I got to know a lot of these people, and I met Peter Hagelstein in Maui last year, and he led me on further and just asked him a question, and he thought about it overnight and came back and told me, yes, that possibly could happen. So we've been trying to improve on the system since that time. The question always arises is, you don't really have excess heat, you're just making mistakes in your calorimetry, in your measurements. Well, I want you to understand, first of all, my measurements are not in test tubes. This is half of a rotor that's been cut in two that runs inside our pump. At the time Gene and Jed came to our place, Gene's been there twice now and tested. Jed's been there probably 6 or 8 times. We were running what we call a 12-inch pump run with a 40 horsepower motor. This particular pump required a 100 horsepower motor and was getting out 138% of the energy out in the form of heat. This film that I'm going to show you is, we did it ourselves. It's a very brief film, but it gives you an idea of how we test so that there won't be any question on how we do our calorimetry or how we do our testing.
That's a very nasty question, because I've got a lot of people in this don't think about metallurgy. What alloy is that component?
6061 aluminum.
Are there any permission, steel, stainless, or anything like that?
In operation right now, no. Yeah. After we see this, I'll answer any of your questions, but this will give you a basic idea of how we test. That's what always came up. Well, how do you do your testing? That we did a little short presentation in Maui. That was one of the questions. Since that point in time, we have changed a lot of the testing parameters. I said it jokingly this morning, but I would like to hire Ray if he can operate on that kind of money, because I ran this company for 2.5 years out of my pocket and spent about $400,000. Last year I took on a partner and he put $600,000 in. So.
In today's fast-paced and ever-changing world, if mankind is to continue to live and prosper, we as human beings must be able to accomplish 3 things. First, we must find energy-efficient solutions to our present consumption levels of fuels. Second, we must make sure that these efficient energy sources do not further damage our planet. And third, we must be able to find an adequate source of clean and pure water. To combine these 3 goals has been a very difficult task. It has been a very elusive goal for both government and private projects. Today, however, because of the efforts of those committed to the energy efficiency and environmental safety, a new invention exists that can truly change the way we as a world and as individuals think about energy and our planet. A revolutionary new concept in energy has brought into being a new device called the hydroponic pump. Here is Jim Griggs, president of Hydrodynamics Incorporated, to tell you about this amazing device.
What you're about to see is a short video on the hydroponic pump. The operation of this invention is based on the theory of the heat transfer that takes place during the production of a shock wave in a fluid. We all learned in high school science classes that energy can neither be created nor destroyed, only transferred from one medium to another. Welcome to a new era in energy efficiencies.
What you're looking at is a test facility for testing hot water with a hydroponic pump. The input water source is city water pressure fed into a 120-gallon reservoir tank. The water exits the bottom of the tank at approximately 75 to 80 degrees. Temperature is confirmed through J-type thermocouples, which are connected to a data acquisition system, which will be monitoring the entire test. The water travels down the feed source line and through a turbine flow meter into a second turbine flow meter for verification, and then directly on into the hydroponic pump. The input power source is monitored by a LeBeau's port meter, which you see on the left, and then the pump runs, the water is exited out the right side of the pump, once again monitored with J-type thermocouples, and through a hose line that feeds directly to the outside where the water is running onto the ground. When the test starts, this water line will be placed into a 55-gallon drum and a stopwatch started to take the time of the test run. During the course of the test, the data acquisition system is monitoring all the activity of the system as well as the time to compare with the stopwatch. At the end of the test, all this data is assimilated and a COP derived at to show the excess heat. The Dranix 808 is used as a verification for input power, and when the test is completed, the hose is removed, the barrel is then weighed for verification of the test. All of this data is available to you here at the conference. The setup for steam testing is a little different. We take and feed into the pump by a standard condensate return feed system as it would be for a standard boiler, either gas or electric conventional system. Once again, coming into the feed line to the pump, we monitor the temperature of the water with J-type thermocouples, monitor the input power with a LeBeau's torque meter, and feed the water directly through the pump, this time producing steam instead of hot water, measuring the outlet temperature with thermocouples on the outlet side, feeding across a regulator valve that regulates the pressure or the temperature of the steam into a flash or separation tank, and then directly to the atmosphere. As you can see, we're operating this test at approximately 70 pounds of steam pressure and exhausting the steam to atmospheric conditions. Once again, the data has been collected and is being assimilated into the computer, which in turn will provide us with specific data sheets which are recorded once every minute, and these data sheets are available here at the conference. As you can see, the system puts out quite a bit of steam with a size unit in comparison with a standard boiler. What you're seeing here is a commercial hot water system for both process and domestic use water. This system heats water at approximately 45 degree delta T at a flow rate of around 5.5 gallons a minute. Inside the luminescence, you see blue bubbles in the water. We see blue steam coming from our pump. The excess heat is only one of the anomalies of this system.
At the beginning of this video, we talked about the 3 things we must do to make our world environmentally safe and energy efficient. We have just introduced you to a device that can meet those requirements, the hydroponic pump. For more information on this revolutionary new device, contact your local dealer or contact the manufacturer, Hydrodynamics Incorporated.
Our test is very straightforward. We take a measure of the water, measure the water both from the flow, meter input the water, and take a temperature, leave the pump, and then weigh the water for verification. On the hot water side, it appears that the excess energy, depending on the design of the pump, will range anywhere from 10 up to about 30% excess. On the steam side, the excess ranges anywhere from around 125% up to in the neighborhoods of 150 to 160% on some of the testing that we've done to date that I really had information available for. Uh,
Can you just mention how the first works for people to call it out?
yes, I'm going to do that. The one thing that I will go ahead and cover, because a lot of people think of it and pointed out, is you noticed in that particular test, when we made steam, we ran it through a separation tank and then just exhausted the steam to atmosphere. The reason for that tank was so that if any of that steam is condensing back to a liquid, we can catch it through a trap at the bottom of it and weigh that steam. If the Tupperware tub you saw at the very first of it has graduation marks on it in tenths of a gallon. And we weigh the water that we add to the system. And we want to be sure to subtract any water that's condensed back away from it. Well, everybody thought that was a good idea, but everybody came up with the question also, what's the quality of the steam? If there's still water droplets in it, it didn't turn it to 100% steam, so therefore you didn't have as many BTUs in it as you're calculating. So what we did, we took that same test and put that steam line you saw into a 55-gallon drum with 300 pounds of water in it and measured the temperature of the water at the start of the test, sparged all the steam, forced it to turn back to water, reweighed the barrel at the end of the test, and calculated the temperature rise of the water that the steam had been sparged into and the added weight that the steam added to the barrel, and used that as our energy output from the device. And those particular tests generally come out around 40% excess energy.
Is that going to be reasonably big enough, or I can?
That's the very last picture.
Okay.
There we go.
Yeah, let's,
I think it'll be,
that'll be.
can y'all see that? Okay, that's big enough. This is just the configuration. We have an electric motor through a coupling driving the pump. Go ahead, Gene, next slide. The reason I show that particular pump is because I brought the rotor out of it. Something happened when we changed the design, and I'm going to discuss that with you. Is that focused to y'all? I can't see it without my glasses anyway. Sure, I will. This is basically the design of the pump. You have a aluminum rotor, which is solid aluminum, connected to a stainless steel shaft that's run through two mechanical seals and then externally to two bearings, and then it spins inside an enclosed housing, and the blue around it is the very close tolerances. Depending on whether we're making steam or hot water, these tolerances generally range from 125 thousandths on the low side to about 250 thousandths on the high side. The housing and end plate material of the pump is made out of 1020 carbon steel, and the rotor itself is made of 6061 alloy aluminum. The shaft is 304 stainless steel. The springs to all the seals are 304 stainless steel. The water is put into the pump here, circulates, and depending on the water flow, it comes out here as either hot water or steam instantaneously. In the steam test, you regulate the water flow so as it goes in, it comes out as steam. To change it from steam to hot water, you either change the rotor design or increase the water flow to the point that it can all flash off into steam. That's the basic design of the pump. As I told you at the very beginning, my concept behind this was to try to create shock waves of very short duration. And I initially thought that that's where the temperature transfer into the fluid was coming from. Because if you go back and you start studying shock waves a little bit, you find out, especially in water flow, whether it's laminar flow or the dynamic viscosity of it, that there is some tension there or friction, and I thought that's where the heat was coming from. After learning a lot about the cold fusion industry and specifically sonoluminescence, I found out that there's a tremendous amount of heat created when you collapse tiny bubbles. And one of the things that we always saw when we would run the pump is that the water coming out of the pump became aerated, had a lot of bubbles in it, regardless of what you did. So I was studying in all the sonoluminescence and information that I could get a hold of. I found out that they were putting a sound horn on a beaker or whatever they were doing and injecting a sound wave through that water. And I asked Peter last year, could you possibly induce a harmonic resonance mechanically, simply by vibrating the water, sufficient to cause bubbles to form and collapse or oscillate? He said he thought that you could, and we went back and kind of based our research all of this past year along those lines. And got to apologize, I had a presentation prepared and it's laying on my desk in Rome. But going back and looking at some of the studies that's been done on sonoluminescence, specifically from the University of Illinois, and Putterman and Barber from UCLA, have concluded that the radiation pressure of a resonant sound field in a liquid can trap a gas bubble. At a sufficiently high sound intensity, the pulsation of the bubbles are large enough to prevent its contents from dissolving into the liquid. And for an air bubble in water, a still further increase in intensity causes pulsations to become so enormous and nonlinear that supersonic inward collapse of the bubble concentrates the acoustic wave over 12 orders of magnitude. Well, that led us to believe that if that was happening on the rotor surface itself, we should start to see some kind of cavitational damages. And we wanted to, because our rotors were made of solid aluminum and the surfaces all the way around this thing are machined to a perfectly smooth finish all the way around it, we've got pumps that have been running for 4 and 5 years that have no cavitational damage at all. As a matter of fact, one of our sales points is that this machine is self-cleaning. Unlike a boiler, you get no scalar buildup around our pump or around the housing on the inside because of the acoustics that are going on. Well, we were extremely happy about that, but we said, well, if these bubbles are collapsing, we've got to find out and know. So we searched around and finally found a piece of glass to replace this housing with. We spent $1,800 for a piece of glass and the machine work to get this pump ready. The glass was a piece of special made glass that somebody used on the space shuttle. It was to withstand 450 degree temperatures, which we felt we were all right, and 125 pounds of pressure. So we said, well, we'll just operate at low steam pressure. Put the glass housing on, cranked the pump up, and within 3 seconds it blew a hole out in the glass about the size of $50. Isolated hole just like you'd cut it in the glass. Got us a little bit concerned about what was happening, and right about that time we met a gentleman named Dr. Sam Martin from Georgia Tech. Dr. Martin happens to be a water hammer cavitation expert and has numerous papers on the subject. I went down and talked with Dr. Martin, and he got real fascinated in the idea that we had used the effect of cavitation to create heat and that we weren't getting any damage. So we started looking at ways to try to prove whether sonoluminescence was actually taking place, whether it was straight cavitation, what size bubbles they were. And rather than read some of the stuff that Barbara and them done, I'm going to try to speed through this and just give you an idea about what we have found out recently. We got thinking about if this is a sonoluminescent effect. There was a lot of work done on the radius size of the bubbles, and if you could create the proper radius size, you could get maximum heat transfer. So we changed the design of that particular pump. And we'd gotten, in our best test with that particular pump, we'd gotten about 140% energy out versus energy in. So when we changed the design of it, we hooked the pump up, and I don't know, can you change the slide? I don't know if you can see. This goes back to one of the things that led us to believe it. In many cases, our steam comes out with a blue tint to it. Next slide, please. This was an old graph showing BTUs out at start, BTUs in, and then the leveled off state. And as you can see, there's some fluctuation there, and that's because the flow rate in the pump seems to fluctuate a little bit when you're just running standard pressure. I can't answer that yet. I'm not trying to be a smart aleck when I say this, but I'll do any kind of testing you want to do if you'll pay for it. Okay. I'll get to that. Next slide, please. Okay, this is the rotor that I have with me here. As you can see, it may be kind of hard to see, but no longer is the surface of this rotor smooth. It has been eaten away. We had done a brief energy check of this pump, and it seemed the energy output had gone up by about 10% over our previous test. But this pump has only been run for less than 3 weeks. What I had my machinist to do was put it back in the lathe and just cut it out and cut a cross section of it. We have sent the material of this pump, you can go to the next slide, off for spectral analysis to see what happened to it. But as you can see in places, and you're welcome to look at this, there are places on this pump where there are grooves cut in the side of it that are very symmetrical as far as the way it works, almost like a wave was carrying around it. We took and put it under a microscope and looked at it, and after looking at it under a microscope, came to a very unique, I guess, conclusion that this is not standard cavitational damage to this pump, and that was confirmed by Scott Williams and Dr. Martin at Georgia Tech. What has happened is that the surface of this pump has gotten so hot that it actually melted the aluminum. And in other places on the surface of it, you can see little mounds that are built up. It has been welded back together. Now, the temperature to melt this grade of aluminum would have had to exceeded 1,200 degrees Fahrenheit, and to weld it back together would have had to exceeded 4,000. You can't get that temperature out of a 100 horsepower motor. So we think we have stumbled across something that may lead us along the lines of proving this collapsing bubble thing that Putterman and all these people have been working on. You can go ahead and go through the slides. One of the unique things is you'll notice right here there's a ridge on the pump, and right here it's almost like it was shot with a bullet. And there's nothing inside the housing that would have caused that, and had a piece of metal or something got against it, the tolerances are so close that we've cut a groove in it. We can see that. There's no damage to the housing at all. None. 3,600, a standard AC motor right off the shelf. It appears to be just melted. I only sent it off for analysis on Wednesday. I don't have the report back on it, but this is 6061. Okay.
What is the hardness of the aluminum rotor compared to the housing?
The housing is much harder. It's 1020 carbon steel. Next slide. Next slide. I hope you can see this. We were real excited. We only found out about this on Tuesday of this week. So we bought an adapter for our microscope, took cameras, ran up yesterday and took pictures, actually Thursday, and took pictures. But this is the surface of this rotor that you're looking at. And you can see the craters and holes here and the darkness of the coloration here. And it's very hard to look at it through a microscope because of the depth. The depth of the field looking at it was real hard. Next slide. We sent these out to have them developed and sent them to a 1-hour photo lab, and didn't tell him what he was looking for, and he thought he was seeing a blur, so he kept overexposing them, trying to bring out what we should have been dark to start with. But it gives you some idea of the depth of the pitting inside this thing. Next slide. This is another section on the rotor. As you can see also, we cut sections out of this, and that's what I sent in to have tested to find out what it was. Go ahead. You can turn that off now. That's all. Gene had asked me to come speak to a conference back in September, and that's where that little film came from. And I've had the opportunity since meeting Gene to be able to go to Russia and meet with some of the people over there. And they had some specific ideas on the sonoluminescence effect. I don't know what's happening in the cold fusion field. First of all, I'm not a physicist, and I can't keep up with half of what Dr. Johnson and Dr. Hagelstein were talking about. I'm a practical engineer, and as I started to tell you earlier, I put about $400,000 of my money in this company, and my partner now has put $600,000 in. And we sat down after the conference that I went to with Gene back in September and had a discussion. And this is where I'm going to disagree with you very much on what should come first, the practical end or the scientific end. We have a device that since 1988 has shown excess energy. In 1990, we started a company to sell these pumps. And we developed our literature and our sales pitch around the idea that you get more out than what you have to pay for going in. Well, from 1990 until 1992, I sold 0 pumps. But I kept doing R&D and experimenting. Well, my type of experiment, unlike Ray's, I can't use it over again. If I build a rotor that doesn't work, I pay $2.65 a pound for aluminum, get to melt it down, sell it back for $29 and start over. So that was the type of research we've done over the years. We've probably now built 700 or 800 different rotor designs. But we did sell some pumps in 1992 that went in a fire station in Albany, Georgia. If you remember the end of that film, that hot water system I showed you, there's been a pump in a fire station down there running for 2 years now, and all of his calculations indicate that pump's putting out about 36% excess energy. In September, my partner and I sat down and said, we can't go on like this forever. We'll never please the scientific community. There's been 100 people come here and do tests. All of them, by the way, no one's ever come to our business and said that we weren't producing steam or heat. They've all said, we don't know where it's coming from, but you're making an error somewhere in your calculations. We'd let them do the testing. There was always an error in the calculations. In October, we decided to go into production of this thing and sell it. We changed all of our literature. There's some literature. There's copies of the tests to go with that film. There are a few of those film over there. We changed all of our literature and said, we're just like an electric boiler. We're 100% efficient. And we moved from Cartersville, Georgia to Rome, Georgia. The film's got the wrong address on it. And went into a bigger facility. From November till today, we've sold over $250,000 worth of pumps and have another 150,000 orders in the house. I tried for 2 years to get Georgia Tech, and I have a friend up here who's a graduate of Georgia Tech. He came out and looked at the pump one day, and he found another anomaly I'm going to talk about later, but tried for 2 years to get Georgia Tech just to talk with me about this system. And they said I was an idiot, forget it. Said it was 100% efficient and it was caused by cavitation, and the head of one of the departments wanted to get involved in experimentation on it, and Georgia Tech Economic Development Department gave us $3,000 for him to write a report on why we should get $150 for a study. Georgia Power, our local utility company there, for 3 years they had been coming out to the building telling me how crazy I was, even though their drainage machine was indicating why I was crazy. Would not talk with us. They have a development center downtown Atlanta where they put new technologies. We changed our literature, said it was 100% effective. They met with us last week and want to put it in their center. I'm tired of fighting the scientific community. I'm going to sell systems.
Okay, that's right. I may be wrong on this because I haven't followed. Have you spoken with the Seth Putter about this? Because you gave a talk at Harvard, and I believe one of the problems with simultaneity, it works in some liquids and it doesn't work in others. I think it works in things like carbon before. I think, for example, it doesn't work in water.
Yeah.
They can't get their experiments to work in water. Which people don't understand about
The
carbon is chloride, benzene, or something like that.
The answer to the first part of your question is no, I have not talked to Dr. Putnam. I have called out there about 15 times and I've never got a phone call in return. When I first read the article and I called Gene, I talked with Ron McCubry at Epley and a number of other people, but they're just... The other thing is about water. We have run different solutions through this pump, and that's one of our sales ideas about it. I've run salt water through it and distilled the water off and ended up with sludge material and pure water. I've run used antifreeze through it, boiled the water off the antifreeze and ended up with concentrated ethyl alcohol. We are right now in a research project with a company out of Rome and Delta Airlines out of Atlanta. One of the things we just found out about it is that when you put certain, I guess, heavy metallized waters in it, it actually causes a bonding between some of the metals, and they become heavy enough that they precipitate out of the water and you can collect them. In the electroplating industry, nickel specifically is a problem they just can't get rid of. What they do is they dip a piece of metal in nickel, then they wash it in just a plain water solution to get that excess nickel off of it, and that water becomes concentrated with these parts. Right now what they're doing, they're trying to filter that out of it and then dilute it to the point that they can put it back down the drain. Well, we found out that we can take that 10,000 gallons of water they have, run it through our pump, get 9,500 gallons of water back and 500 gallons of what they can pour back in their starting bath to begin with. So there are all kind of unique benefits, and that, I'm going to use this for a sales pitch, Gene, about what our pump can do versus conventional boilers. You cannot do that with a conventional boiler. They'll cake up and corrode the boiler will go away in less than a year. Let me finish and I'll come back to the questions, okay? In an electric boiler operation, and we've talked with the boiler manufacturers, an electric boiler is exactly 100% efficient at startup. And from that moment on, the efficiency of that boiler declines because you get scaling and everything around the electrical elements of the boiler. Boilers need blowdown. We don't need any blowdown. There's nothing builds up, it just goes away with a solution. There's no chemical requirements to treat the water with our pump because it's self-cleaning. There are just a lot of unique things about it that make it a little better than a boiler. The excess energy was the thing that we kind of hung our hat on for 4 years. And I think that sooner or later, one of you are going to prove the excess energy theory works. And that's why I was real interested in some of the things you had to say, Dr. Johnson, and some of the things we've seen in different testing. But I think one of you will prove there is a reason behind excess energy and can write a theory behind it. I can't. I don't care. I'm to the point now where I would love for y'all to prove it. That will give us great benefits as to our sales applications down the road. There's one other phenomenon that occurred, and we still don't have the answer to it. If you were looking at this rotor, it normally would be a solid piece of metal, brightly polished, and sometimes you can see the white scale build up here. You will get a little bit of whitening to the metal at times. We had the sister rotor to this one running in an application in a dry cleaner, and they needed more steam, and we happened to go take that one out and put a new one in to increase their production. John Nix up here, who's also an engineer, came to my plant one day, just wanted to come visit, and I said, sure, come on up. And he picked up the rotor and he got to looking at it, and he noticed something on the outside of it that I guess I'm around it every day and had never noticed. On the outside, the wall thickness between the hole and the side of the rotor is 3/8 of an inch. But on the outside of the hole, there was a visible pattern of the exact design of the hole, and it was almost as if you had drawn it on the outside with a black magic marker. We couldn't figure out how you could get the design of that hole through 3/8 inches of aluminum, and we still don't know. John suggested that we put film on it and see if we got any exposure on the film. We eventually sent it off here recently to have it analyzed to see what caused it, but one of the things we did do, we went back and we started measuring the diameter of the hole because we knew what the hole diameter was before we started. And after these rotors had been run for a while, we've noticed that the diameter of the hole in these, even though they haven't got degradation and deformed to the extent of erosion, had expanded by as much as 50 and 60 thousandths. That means that the pressure inside that hole had to exceed thousands of pounds of pressure. And that was one of the things that Dr. Martin put to us, that when we blew the hole out in the piece of glass, that the collapse of the bubble at the impingement point might be as much as 5,000 pounds. So that was just something else that was anomalous about what we were doing that we didn't understand. And you should not be able to create those kind of pressures simply when you're putting in 150 pounds of input water pressure on this particular pump. But those are just a few of the things that we've learned. We've been asked to do many, many experiments, and we've tried to do some of them that related back to cold fusion. Gene mentioned Dennis Craven. I met Dennis last year in Maui, and he just had faxed Jed a thing and asked us to put potassium carbonate in it. We haven't got around to that. Since we've started selling, we haven't got around to doing any testing. I've run one set of tests yesterday just to confirm, to make sure that, like magic, this effect had not gone away before I come up here. It had not. We've been asked to run different chemicals in the water. We actually had an opportunity where we got to mix, I think we put in, Gene, do you remember, was it an ounce he gave me, or so many liters of heavy water and 20 gallons of light water?
About 50 milliliters of heavy water was dumped in.
And back then we didn't have a data acquisition system. Everything was done manually. It appeared that it increased the production of the pump maybe 3 or 4%, but that could be accredited to error in our calculations. Other than the chemicals I've told you, they have run a petroleum-based product through the one that's in Albany, or one of the ones that was in Albany, to see if it would actually heat diatherm, and they didn't have as good a results as what they were wanting. I don't know the final results on that yet. But that's the extent of the chemicals that we run through it. I'll try to answer any questions. And
I'd like to make a comment question. As being a person in the cold fusion field that came to see this, is quite astonished and convinced beyond any reasonable doubt this is a real phenomenon with this device. I urge someone in the field to come up with what I wish we had been able to do about a year ago, and I hope this will be done ASAP. Jim, you can run this closed loop.
yes.
You have a tank of water, and you can just generate hot water or steam. You can just keep it going around in a cycle, right?
Well, to the extent, yes, depends on what your pressure vessel is. As you know, with the hottest we've ever got the water, we keep it under pressure, and we run the water up to about 380 degrees, and then we have to shut the system off and let the water cool.
Just because the recirculating pump
Right.
is
Well, that and the fact that the tank can't hold it. It can't hold the pressures and the temperature.
Here's the point. Here's my suggestion that I think the field must do. Someone's got to do this soon, and that is to completely analyze the water and material content at the start of such an experiment, and then run it for days or weeks, or whatever you're going to do. And if this isn't an energy amplifier, as we believe, it's some unusual effect, if it were nuclear, let's say, which perhaps it is, or perhaps it isn't, who knows. If it's nuclear, you're going to see the helium-4 transmutations or whatever. If it's not nuclear, you're going to see nothing. Or you'll see the effect peter out. And I urge the field, whatever resources there may be, to do that experiment. It's a shame that we haven't been able to do that. Not your fault.
I would point out, along the lines of what Gene just mentioned, even before I knew Gene and knew about the cold fusion field, we have an open door policy at Hydrodynamics. If you would like to come visit us, call and set an appointment and come on. If you would like to come test and use our equipment, come on. If you'd like to come test and use your equipment, come on. If you want to do experimentation on the pump that you're going to fund, come on. We've got an open door policy.
I just want to say a little things here. First of all, I'm very much impressed, let me tell you. And one thing that I like very much, I see here a man of action, serious man, with his company, with his device that he's showing us here. Very interesting. Now, in addition to what Gene, I was just about to say that I absolutely agree with him. I'm willing to go. I know that there's one amateur scientist, a dabbler in the field. I'm following the internet discussions. There is one guy called Tom Drugi from University. Fermilab, exactly. Now, why do I say dabbler? I mean, why do I say amateur? I followed his postings. Maybe he's competent in other fields, but not exactly in this. So he's going to be visiting you, as far as I know, and I'm willing to. When?
March the 8th. He is
So I'm willing to also come and do some experimentation, but probably we should. I'll give you my calling card. We probably should contact each other. But now I want to say something about the science and technology. Now, I am of the opinion that probably there's a little misunderstanding. Believe me, if a scientific community now was behind you, and if you have proven this for sure that this is an unusual effect, you will be Ross Perot now. Probably you will be running for president of the United States. Not $500,000, but maybe you'll have $2 billion in your company. So this is the importance of science versus technology.
No, no, excuse me. That's a fundamental misunderstanding, I think, and I appreciate it because you have not studied, I think, the media and the politics of this as much as I have. You're probably a good scientist, and I'm an engineer, okay? The scientific community will not accept
I
this.
don't think so. If you
No, they will not. I'm
present
sorry.
clear arguments, I don't think
No,
so.
no, they will eventually accept it. I will tell you when they will accept it. They will accept it when the device self-sustains. It doesn't matter which one it is. That's the only time they will. But let's not get into that. Okay, let's let Jim finish off. Thank you for your comments. Yes, Prasad.
Now that Jim has said it, that Naveen has said that you could circulate the water again and again, and you could raise it up to 176 degrees centigrade, that's about 315 Fahrenheit. It looks like you should be able to sustain it because you should be able to have a reasonable heat engine with this much of a temperature.
So what happens is that you have a constant delta T across the pump. Regardless of the temperature you put into the pump,
Okay.
it's going to raise it. This particular pump will raise the temperature about 100 degrees Fahrenheit at a flow rate of about 7.5 gallons a minute. And if you put in 100 degree water, you'll get 200 out. If you put in 200 degree water, you'll get 300 out. And that's the problem we've had in putting them in closed loop and running them all the time, is that unless you have some mechanism for taking that heat away, then it will just continually build and build and build. Right.
What kind of pressurized do you get? What kind of pressurized do you see across the pump when you just run it normal?
If you run it normally, you do not measure on the hot water side a pressure increase. If you just have a standard dial type pressure gauge on the inlet side or one on the outlet side, they'll read within a pound or two of each other. Now on steam, we increase the pressure in the pump to cause a flash point to change to bring it to steam. And we generally will have about, from the input pressure to whatever outlet pressure we run it at, we generally operate at about a 25% drop across the pump. The problem that we didn't know is what the internal pressures of this pump is. One of the things we're doing right now is we've ordered some accelerometers, and Dr. Martin's actually taken a housing and drilled holes in it to place temperature and pressure probes right at the surface of the housing wall around it at different locations, so we can measure the pressure points as these holes pass. One other quick thing that I'd like to mention real quick, Gene, is that everybody talks about enhanced energy, and Fred mentioned it this morning. I might also mention that Fred Yeager of Eneco sent an engineer from Marietta, Georgia, who builds testing equipment for people like Westinghouse and Ford, because Fred was interested in talking to us about becoming part of Eneco, and we had breakfast together this morning. But he sent his engineer up and tested it, and his engineer sent a report back to him that we were 138% efficient, and that he better act.
I guess the thought, a self-sustaining device in this case would be to have a turbine that turns this thing after the motor's gotten everything going. Have you looked at what the efficiencies turn out to be and what kind of that's included? Have you thought about that?
Are you talking about taking
your running a turbine that would turn this?
Because of the inefficiencies of most turbines on the market today and the fact that the motor only runs at about 88% efficient, we're going to have to get the pump up to about 245% efficient before it can be run with a turbine. But I will tell you another aspect that we've entered into a research project with. We can take a windmill, and by gearing this thing properly, let the windmill run whatever speed it wants to run and run the pump at a constant speed. And we can produce enough steam to run a turbine now instead of having to go through a conversion process with a windmill. And we can make a windmill 85% efficient, where today they're 35% efficient, and use the steam to generate electricity and condense the water and use the water to heat homes or buildings or anything else you want to use it for. And we're going to put a windmill on top of an 8-story condominium at Key Biscayne, Florida, and try to run 350 condo units with one. That is enhanced energy.
Thank you.